bow of a ship has to be a compromise between sharpness, to reduce drag, and width, to increase capacity and stability. But what about its side profile? Again, in the Empress of Ireland video we saw two examples of different profiles. The Empress with her straight bow, which makes sense from a logical perspective, and the Storstad with a tumble home bow, which proves so devastating in the collision. A tumble home bow is one that slopes inward the higher up you get. It creates this protrusion underwater and results in a shape that is much easier to cut through heavy seas. As waves ride up over the bow, there's minimal increased displacement, meaning that it's less likely for a ship to pitch up and down. As these ships move along, they just look solid and they appear to cut through the waves rather than ride them. Unfortunately, however, as we saw with the Empress of Ireland, when one of these tumble home bows is involved in a collision, they inflict an immense amount of damage under the waterline of the other vessel, drastically reducing its chances of survival. So much so, in fact, that this very incident was the catalyst for the next evolution in the design of ships' bows, the flare. A flared bow is one that sticks out much further as you get higher up. The idea with these is that they're much better at riding waves because as the wave approaches, the water encounters more hull, increasing the buoyancy and lifting the bow up with the wave. Where the tumble home was prone to punching straight through a wave, the flare increases a ship's ability to ride the wave. And, unlike in the Empress of Ireland incident, a flared bow is going to do a greater amount of damage above the waterline in the event of a collision, but the vessel that gets hit is at least more likely to maintain sufficient watertight integrity to remain afloat.